Hey guys, recently I played around with Warudo and wanted to share the method I used to recreate camera-sensitive floor reflections for your avatar. My approach is probably a bit wonky in some aspects, especially the OBS setup itself, because I don't work with OBS very often. I simply used the first solution that worked, so there are probably better options for optimization. If you see anything that can be improved, please let me know in the comments. Essentially, you'll need Spout 2 installed in OBS, a few cameras in Warudo, a custom blueprint, and if the reflective area needs to be limited to a certain shape, then you'll also need a prop consisting of a plane or any custom shape made in Blender. The prop must be 100% white with non-reflective material applied. The masking method that uses a prop will only work if you don't use other props in the scene, because the prop itself acts as a mask in OBS. Unfortunately, at the time of writing, Warudo doesn't allow selective prop rendering for cameras. Maybe they'll change that in the future. Let's begin. You'll need a main camera that renders your avatar normally, second camera for the reflection itself, a third camera for the environment, and one more for the mask if you need one. The sad thing about the whole approach is that it's kind of limited to the worlds that don't have any assets in front of the character, because everything is separated to layers and what is behind can't render properly as if it was in front. But if you use some sort of stage or semi-empty room, it could be useful. First, set up the rendering filters for the main camera so it doesn't capture the prop and the environment. Make sure the output is transparent. You'll also need to enable Spout 2 output for each camera so OBS can see them as separate capture sources. Add it as a spout source in OBS and rename it accordingly so you don't get lost. Next, you'll need a separate camera for the reflection, since the reflection has to show the avatar from a different angle than the main view. I must point out that it still counts as double rendering, so maybe don't do that if you have a weak PC or if your avatar is very complex. The second camera should also have spout output enabled, same settings as the first one. The third camera should only capture the environment if you use it whatsoever. Let's move on to the blueprint setup. This is where things get a little tricky, so I'll explain it step by step. The initial idea is that if your main camera changes position for any reason, for example, if it follows your movements or has a predefined movement pattern, the rest of the setup should follow it as well. A little note on the blueprint nodes. I believe most of them are departed of default Warudo setup, but I'm not 100% sure because I had some add-ons pre-installed. So in case you won't find something, let me know and I'll add it to the list of add-ons in the description after the video is released. If this is the case, apologies for the inconvenience. I promise it's not as difficult as it seems, but you need to be very precise with the way you write the numbers, so please be careful. First, you add get asset transform, which feeds the main camera's position and rotation data to the target asset, in this case the other cameras. Then add the compose transform, which separates the data into what we need to adjust: position, rotation, and scale individually. We don't modify all the scale in this tutorial, so just leave it as it is. Next, we use decompose vector 3 to gain individual control over each axis of the camera position. Now, another important note. These values are tuned for a floor reflection setup. If you want the mirror effect to be on a wall instead, you will need to adjust both position and rotation in some different way. The values that don't need to be changed can connect directly to the following node. If something needs to be changed, we use formulas. If you just need to invert something, just multiply this value by -1. After that, you recombine everything back into vector 3 and then move on to the rotation settings. For the rotation, you need to recreate the node tree with the same nodes as for the position, but with different adjustments. Everything is then recombined back into the transform node and then to the final one. The on update node allows you to see the result in real time. Transition time should be always set to 0, since we want the changes to apply instantly at all times. This whole node tree is what you feed into your reflection camera node, so it starts copying the main camera, but there is a trick to it. If you were to originally recreate all that facing the proper direction in Warudo, your reflection would be looking as if you just copied an avatar and rotated it 180 degrees, which would be a problem the second it starts moving. Therefore, this whole tree is adjusted to be flipped afterwards. Now, let's move to the simpler part. The other two cameras don't need any of these manipulations. You just feed them to the original transform data as is. That's pretty much it if you don't plan to use the mask prop. We just switch the OBS, flip the reflection output, and you're good to go. You can apply one of those color filters on top to make it look resembling an actual mirror reflection, which sometimes has lower saturation and stuff. If for some reason you need to mask the reflecting space, then here's what we need to do additionally. But keep in mind what I said in the very beginning regarding the usage of other props. If you have any other props in the scene that you plan to use at the same time, this method would work for you. Add the white prop that you're gonna use to the scene and place it where you want. Now add the new camera to track it. Make sure that the camera renders the background pure black. Add the camera spout in the OBS and add a green screen filter to it to make sure that the black is removed. Now we want to use this OBS spout as a mask for the reflection, but it doesn't rotate yet. Since our reflection is flipped, the mask logically should be flipped too. Do that so in OBS and then switch to the blueprint back. You need a similar setup for this camera as the piece of blueprint that we made previously, but it uses completely different data. The only thing left to do is to enable it as a mask in OBS by adding an advanced mask filter to the reflection spout. And this is how you create a floor reflection in Warudo in OBS. I hope that this tutorial will be helpful to you and thank you for your time.